So yeah, what we're going to be doing today is calculating molarity. Now, molarity is the units we use in chemistry for concentration. Okay, and molarity is pretty simple. Molarity is just the number of moles. So let me write it over here. So molarity, again, it's the common concentration unit we use in chemistry. It's represented by usually a capital M. It's usually like a fancy capital M. Okay, and if you ever see a brackets with some sort of chemical symbol in the middle here, so let's say, for example, HCl or something like that, this means concentration in molarity. Or just simply molarity, but I'm just saying concentration because this is a concentration unit. Okay, molarity is concentration unit. And what molarity is, it's really simple. It is the number of moles of solvent in 1 liter of solution. As you know, we've been talking about solutions, right? And we haven't talked about solutions quantitatively, but today that's what we're talking about, solutions quantitatively. So molarity is simply the number of moles of solvent over 1 liter of solution, okay? So if we want to find the molarity of a specific substance, we need to know the number of moles of something and the number of liters of that solution. So number of moles in number of liters. So there's 2 ways we're going to look at this today. There's kind of 1 through 9 here are one way of looking at it, and 10 through 18 are another way of looking at it. And we're just going to figure out these 2 today. Number 1 through 9, you're going to be either given the number of moles and liters, or like moles and milliliters, or you can be given grams and milliliters and grams and liters. Okay. So you want to find molarity of a solution, and we're given number of moles and liters. So let's say, for example, I'm not even gonna do any of these as examples. I'm just gonna make some up. So let's say we have 5 moles of HCl and 0.5 liters of solution. So this is very similar to like number 1. So you have 5 moles of HCl and 0.5 liters of solution. This is very, very simple. We have moles and we have liters, so we just take 5 moles and we divide it by 0.5 liters. Okay, and when we do that, we should get 10 moles over 1 liter. Okay, all you're doing here is you're taking the 5 moles and dividing by 0.5. So 5 divided by 0.5, and we should get 10. Okay, and then that's 10 moles in 1 liter, and we would say that's 10 molar HCl. So you'll see a capital M, 10 molar HCl. Really, really simple there. Okay, so let's say, that's one example here. Let's say we're given number of milliliters instead. Let's say, for example, we're given 5 moles in 500 milliliters. This is the same problem. What we need to do first is we need to convert this milliliters to liters. So in order to convert milliliters to liters, you could do it one of 2 ways. You can leave it in this form here, or we can convert it. So we can do it this way. We could say, okay, well, there's 1,000 milliliters in 1 liter. Okay, or we can just do it like, say, 500 milliliters, and 1 liter is 1,000 milliliters. Okay, in this case, we get 0.5 liters. And in this case, we're just going to do it all in 1 step. So in this case, we do it all in 1 step, and we'd get 10 molar. Okay, so this one If we convert the milliliters to liters first, we get 0.5 liters. And then we have to go back and plug it back into the original. So 5 moles over 0.5 liters. And we still get 10 molar. So you could do it either way. You can convert the milliliters to liters in the molarity formula, which is moles over liters. So this is moles over milliliters. Now we're just converting the milliliters to liters. Or we can convert the milliliters to liters first, then plug it back into the molarity formula, 5 moles over 0.5 liters. So when you're doing these problems, again, you need moles over liters. So the whole idea here, we got to convert. If we're given moles, we're good. If we're given milliliters, we got to convert to liters. Okay, we can do it one of two ways. We can either do it in the formula, so 5 moles over 500 milliliters, and then convert the milliliters to liters inside the formula, and we get, when milliliters cancels out, we get liters in the end. Or I think a lot of people prefer to do it this way: convert the milliliters to liters first. So take the number of milliliters, divide it by 1,000. Oh, sorry about that. Thank you for letting me know that. I guess when it kicked me off, I forgot to represent. Yeah. Okay, hopefully y'all can see that now. Is that better? Yeah, good. Okay, sorry about that. Yeah, thanks, Kay, for letting me know. Appreciate it. Okay, so again, we can either take the whole molarity thing is just moles over liters, right? So if we're given moles, we're good. If we're given liters, we're good. If we're given moles and milliliters, we got to convert the milliliters to liters. So again, we can either do it in the formula, so 5 moles over 500 milliliters, and do it this way. But I think a lot of people prefer to do it this way, where you take the milliliters first and convert it to liters. So this way right here. So take the milliliters, convert it to liters, and then plug it back into the formula. Okay, so that pretty much covers number 1 through 5. So 1 through 5, you got to put the moles over liters, moles over milliliters, convert the milliliters, all that good stuff. Next ones, we're given grams. So we're given grams of the substance. So like 120 grams of calcium nitrate. So I'm just going to make up another one. Let's say we have 30 grams of HCl. In 0.25 liters. Okay, so we have like 30 grams of HCl and 0.25 liters. We have to convert first the grams of HCl to moles. So 30 grams of HCl, and we're going to convert that to moles. So 1 mole over the molar mass of HCl, which is, Cl is 35.4, so it's about 36.5. Okay, again, this is the molar mass of HCl. Okay, so 30 grams, I need to get my calculator. So, yeah, HCO. Yeah, 36.5. So 30 divided by 36.5. And I get 0.822 moles. Let's make it 0.82 moles. Because we have 3 sig figs here. 2 sig figs, 2 sig figs. So let's keep it as 2 sig figs. So we have 0.82 moles of HCl. That's our number of moles. And then it's in 0.25 liters. Okay, so 0.82 moles over 0.25 liters. We divide 0.82 divided by 0.25, and we get 3.3 molar. Okay, so again, we're just converting grams to moles, and then we take our number of moles and divide it by number of liters. Really, really simple. Moles over liters. Always, 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 for molarity. Okay, and then if we were given instead 0.25 liters, if we were given in milliliters, we just got to convert from milliliters to liters first. Okay. So you should be able to do number 1 through 9, no problem. And then you can check your answers at the bottom. I did give the answers there, so try them before you just look at the answers though. Okay, next. Okay, the next part's a little bit trickier, but really not that bad. Okay, so here we're explaining how you're going to make the following solutions. So basically, I want you to tell me how many grams of the substance you need to make the solution, not how many moles. Okay, so for example, let's just say here, I'm going to make up a new one here. So instead of 2 liters of 6 molar HCl, I want to make, let's say, I want to make 4 liters of 4 molar HCl. So how many grams of HCl do I need? Okay, so first of all of these problems, so you're going to have a molarity and you're going to have a molarity and you're going to have a volume. Your volume always needs to be in liters. So at any of these, so all of these, like 45 milliliters, 250 milliliters, you need to convert that to liters. So convert that to liters first. Okay. Basically just divide by 1,000 and then you'll get liters. Okay, for all of those. Any ones with milliliters, convert. Okay. And molarity is, so this one is 4 moles over 1 liter. That's the molarity. 4 molar, it means 4 moles in 1 liter. And we want to figure out how many moles of HCl we need first. So we're just going to multiply the molarity times the number of liters. And it's 4 liters, so 4 liters. Okay, so 4, and then the liters will cancel. You get 4 times 4, so you need 16 moles of HCl. Okay, so we need 16 moles of HCl, but again, we don't want to know moles. We want to know HCl. Like if I wanted to actually make this solution, how many grams of HCl do I need? Okay, so if I'm going to take solid HCl and I'm going to measure it out, how much do I need to make this 4 molar solution? Okay, so I got to convert now moles to grams. So 16 moles HCl times its molar mass. So 36.5 grams of HCl for every 1 mole. Okay, I do that work here. 36.5 times 16, and I get 584. Oh, that's a lot of HCl. Grams of HCl. So I would need 584 grams of HCl in 4 liters of water. Or really 4 liters of solution. It's actually not 4 liters of water, it's 4 liters of solution. Okay. Okay, now that's basically how you're going to attack all these problems here, numbers 10 through 18. You're going to take the number of liters, so if it's milliliters, convert it to liters. Then take number of liters, multiply it by the molarity. Then once you multiply the molarity times the number of liters, you get number of moles. And then convert moles to grams. Okay? And then you're going to put it in 4 liters of solution. Okay, so that's how you're going to do all those problems there. Okay. Now, just let me explain a little bit something. And we'll talk a little bit about, I'll talk about this again when we actually talk about diluting solutions. We're talking about diluting tomorrow. But basically, in order to make this stuff, what we do is we take something called a volumetric flask. So a volumetric flask looks like this. It has a long stem and then a bulb at the bottom. It's a volumetric flask. Okay, and typically your volumetric flask is going to be the size. So here we need 4 liters of solution. So you're going to have a 4-liter volumetric flask. And there's a mark on the volumetric flask somewhere along here. There's a mark. This mark indicates where 4 liters of solution would be. Okay. Now, anytime we have, like, if we want 2 liters, 1.5 liters, 0.75 liters, we're going to have a volumetric flask that is that size. Okay. Now, I mean, we're not going to have a volumetric flask that's 6.7 liters. We would do it a different way, but let's just hypothetically say that we would have a volumetric flask for the exact amount. Okay, if we did something like 6.7 liters, we would use a couple volumetric flasks. We'd probably use like a 5-liter one, a 1-liter one, a 500 milliliter one, and a 200 milliliter one. But don't worry about that too much. Just understand that we've used something like a volumetric flask. And volumetric flasks are very precise. The amount of liquid in here would be exactly 4 liters. Okay. But what we do first, we add a little bit of water to it first. So step 1 would be add a little bit of water. Just a little bit. And then we would add the HCl. We would add the solid. So step 1, add some water. And we're going to use distilled water, or either distilled or like it's deionized. It's called deionized water. So pure water with nothing in it. Okay, so we'd add a little bit of water to it. Then we would add the solid slowly, either the solid or the well, tomorrow we're going to talk about dilutions. So we're going to add something called the concentrate or concentrated solution. So add the solid or concentrated solution slowly. So we'd add it slowly. And the reason we add it slowly is because sometimes when we add solids to water, they get hot. Like HCl gets really, really hot. So we want to add it slowly so that this doesn't get super, super hot and break the flask. Right? We add it slowly. Okay. Then once all the solid is added, then we're going to fill to the line with water. And you'll often see it deionized water, just DI water. So if you ever see this term DI, like deionized water, so fill to the line with deionized water. So we'd add it all the way up to the line, add water all the way up to the line, and then we just stir it until dissolved. Okay, stir until it's all dissolved. So again, when we make these solutions, we're using a volumetric flask because it's very, very precise in the amount of water that it will hold, or amount of solution, I should say, it will hold. Okay. And we're going to add a little bit of water first to the bottom. Then we're going to add the solid slowly so it doesn't get too hot. We're going to add it slowly. And then once we add all of the solid, we're going to fill to the line with distilled water or deionized water. Distilled or deionized water. Okay. Then finally, we're going to stir until it's dissolved. And that's it. Now we have the solution we want. Okay. Okay, so you should be able to do all of those problems. Try and show your work if you can. I would encourage you to print it out and print it out and then draw, right? Or you don't have to actually print it out. You can just show your work on a separate sheet of paper and then take a picture of it if you like. Okay. The answers are here though. Okay. The answers are here. So if you need the answers, they're down there. But do show your work so you can get full credit for it. And I know that you know how to do it. Okay. So that's it. That's it. Molarity. Any questions? Okay. Well, if anyone has any questions, feel free to stick around and ask. Otherwise, you all are free to go, and I will see you tomorrow. Later, Tyson. Later, Kay. Later, Casey. Later, Harley. Bye, Leah. Later, Sienna. Later, Zoe.